Good evening again. Welcome to the live session for the course Advanced Concrete Technology. This is the fifth week. So, without further ado, let me go to the presentation. Yeah, I hope. Wait, let me share the screen. Is my screen visible to you now?
Yes, ma'am.
Yeah. So, this is the fifth week. So, here we have learned more about the chemical admixtures, then the mechanism of action of admixtures, and a little bit about the special admixtures such as the viscosity modifying agents, waterproofing, water tightening, etc. So let's go to the first question. Beyond a certain dosage, the fluidity of the mix by adding superplasticizer does not change because of dash. Sorry, one second. Yeah, yes. So the question is, if you are keep on adding superplasticizer beyond one dosage, the fluidity does not change. So, what might be the reason for that? Let me post the question again in the chat box. Thanks, Shrish, for the immediate response. Beyond a certain dosage, the fluidity of the mix by adding superplasticizer does not change. So, superplasticizer we generally add in order to increase the workability or keeping the workability same, increase the strength or to reduce the cement content, etc. So, we think that when you add more and more superplasticizer, the mix will get more and more fluidity or workability. But the actual situation is that yes, it does increase, but after a particular optimum dosage, it does not further increase. The fluidity does not further increase. So, what might be the reasons for the same? That is, cement particle repels the superplasticizer molecules, or after that optimum dosage, the saturation with respect to superplasticizer adsorption on cement particles have reached, or the superplasticizers will be reacting with the C3A particles, or the superplasticizer evaporates before interacting with the cement particles. Yes, I can see three answers. So, okay, four answers. Shri, Sharanya, and Balu says B. Ria says B. Niklesh, okay. You can just simply type the option. That will be easy for you. Uh, yeah, I'm waiting for more answers. Yeah, Niklesh, no problem. That's just easy for you, I guess. That's why. Then, what else? How many are there? 14 attendees are there. So, shall I wait for some more time? I think this is a fairly an easy question. So, I would like if more of you can answer. Am I missing something? No, right? Yeah. So, where are the other answers? What happened? Are you guys traveling? Are you guys not in a position to type? Okay. So, the correct answer is that. Okay. Now the answers are coming. But still, let me go to the answer. The correct answer is B. So, seeing the chat box, I think that most of you have got it right. So, those who have not answered, is it because of your impression that if you answer it wrong, it is bad? No. Please try to answer whether you're going wrong or right, no problem. This is a platform where we can learn together. So, don't bother about that. Okay. So the correct answer is B, because once you add superplasticizer, the fluidity or the workability of the mix first increases, and afterwards it does not increase further, because for any system there's a saturation point. If you add keep on adding sugar to water and mix it for some amount, it will dissolve. After that, what will happen? It can't dissolve, because the saturation with respect to sugar in water have reached. So similar concept, the saturation with respect to the superplasticizer adsorption on the cement particles have reached, so hence the fluidity will not increase further. So the correct answer is B. Okay, moving on to the next question. As per Aitken, for a compatible combination of cement and superplasticizer, the flow curves from marsh cone test coincide at the time. The options are 0 minutes and 60 minutes, 10 minutes and 60 minutes, 0 minutes and 100 minutes, 0 minutes and 10 minutes. Thanks again, Shrish, for the quick reply. So, Aitken, according to him, he formulated that we have to do the marsh cone test to find the compatibility between the cement and the superplasticizer, because obviously not all the superplasticizers are compatible with a particular type of cement or particular type of binder. So to find that, we can do the marsh cone test. So if you do the marsh cone test, you can see the flow curve at a particular time. So he says that at particular time t1 and particular time t2, the curves coincide. So what does t1 and t2 is the question? Is it 0 minutes and 60 minutes, or 10 minutes 60 minutes, or 0 minutes 100 minutes and 0 minutes and 10 minutes? Okay, I'm getting more and more answers now. Sri Sharad, Riya, Anand, Sharanya, KP Rao, Ravinder Pandey, and Niklesh have commented A. Okay, thank you all of you for commenting. I'll wait for a few more seconds so that if someone else also, yes, uh, Rahman and Balu commented A. Yes, so no one wants to go to any other option. So as of now, all of you have commented A. So moving on to the answer. I hope the answer screen is visible to you. So here it is. This is a flow curve. I just copy pasted from the slides we have. So when the SP is compatible, so this is the initial and this is the after 60 minutes. So this is initial and this is 60 minutes. So if the at 0 minutes and at 60 minutes, if the curves are coinciding, then that particular cement and superplasticizer are considered to be compatible. So please remember the timing, 0 minutes and 60 minutes. Okay. Okay. So moving to our third question. This is a true or false question. The second generation admixtures can increase the slump of a no slump concrete to 250 mm. Stay true or false. Mind you, it's I'm talking about a second generation admixture, and it says that it can increase the slump of a no slump concrete to 250 mm slump concrete. So whether it is a true statement or a false statement is the question. I have received responses from Rao, Balu, Sharanya, Shri, Sharad, and Riya. So majority goes with false, and there are a little bit of true in between. Yeah, it might be a bit confusing because we have three generations of admixtures and different slump levels are mentioned. So here the catch is no slump concrete. Yeah. Let me wait for a few more seconds. Let me see what are there. So I have not heard till from Kaushik. So Kaushik, if you are in a position to unmute, can you unmute? So I have seen all the other names, I guess. Almost all the other names. Kaushik, are you in the meeting? Sharad Jadhav, are you in the meeting? So if you can please unmute.
Yes, yes, yes. I
Yeah.
am in meeting.
Yeah. So what do you think about this question? So what is a second generation admixture and can it increase a slump from no slump?
I think second generation mixture is a lignosulfate type SNF.
Okay.
Uh, so he did not increase much more as it is a PC base.
Yes, true that.
So I think zero slump,
It's not possible.
hmm,
False.
not create to 250 mm, 0 to 250 mm
Okay.
as a SNF admixture.
Okay. So you go with false.
Oh yes, yes,
Yes.
yes.
Okay. Thanks, Sharad. So it's safer for you if you can. I mean, if all of you, not to Sharad, to all of you, please reply in the chat box and be interactive so that we can have an interesting session. So, yeah, the correct answer, as rightly told, was B. So, the second generation admixtures can work at reasonably low slumps. It cannot work at a no slump concrete. It can work at a reasonably low slump, that is 25 to 50 mm, corresponding to some water cement ratio of 0.35 to zero point 0.4, but it can increase it up to 250 mm. That is true, but not from a zero slump concrete. Okay, it can increase, but only from a 25 to 50 mm. So the correct answer is false. So thank you, Sharad sir. uh, yeah, sir, can you unmute, sorry, mute? Yeah, thank you so much. Yes, so we move to the next question. Yeah. Now, choose the correct statements. So, read these statements carefully before you answer. So, it's about reactive powder concrete. So, the reactive powder concrete is also known as high early strength concrete. That's the first statement. Then, reactive powder concrete used only fine aggregate and not the coarse aggregate. Reactive powder concrete is intended to provide a compressive strength of more than 150 MPa. Then, SNF admixture is typically used in reactive powder concrete. So, these are the four statements. So, yeah, I got the answers from Shrish, Riazur Rahman, and Anantraj, Charanya. Let me pause the screen share for a second. You have the question in the chat box. Yeah. Yes, I'm seeing so many answers. A, B, A, B, A, B, A, B. So, reactive powder concrete is also known as high strength concrete and it uses only fine aggregate and not coarse aggregate. Okay. I'll wait for a few more seconds. Okay, so I'll share the screen. One second. Yeah, I hope the screen is visible to you. So the options were, it's also known as high oil strength concrete, and it uses only fine aggregate and not the coarse aggregate, and it is intended to provide a compressive strength of more than 150 MPa, and SNF admixture is typically used in reactive powder concrete. So I have received all the answers as AB or ABC except D. So thank you all for responding. So we move to the answers. The correct answers are B and C. So I can see that only who had commented B and C? Only Anant Raj, I guess, commented B and C. Yeah, I think yes, right? Huh. But then Anant Raj changed it to A and B. Okay. So correct answer is B and C. Why not A? Because it is also known as ultra high strength concrete. It's not high early strength concrete. It is ultra high strength concrete. So it's not A, and it uses only fine aggregate and not coarse aggregate. Hence the name reactive powder concrete. And it, the reason for calling it to be ultra high strength concrete is because it has a compressive strength of more than 150 MPa generally. So B and C are the correct answers, and D, SNF admixture is not used in the reactive powder concrete. Okay, so the correct answers are B and C. No problem for if your answers got wrong. So keep on answering in the chat box. Then only I'll know like how much you're following or are you here. Okay. So the next question is, as the temperature increases, the superplasticizer dosage to produce a given slump increases, decreases, or does not change. As the temperature increases, the superplasticizer dosage to produce a given slump. So this is fairly easy question. Yeah. As the temperature increases, the superplasticizer dosage to produce a given slump. Okay. Thank you, Shrish, Harsha, Rahman, Ria, Om Thakur, Anantraj, and Balu, Nikhilesh. Thank you all for responding in the chat box. Others, yeah, okay. Since I'm getting more responses in increases, let me go to the answer. Yeah, the correct answer is increases. So as the temperature keeps on increasing, the superplasticizer, more of hydration takes place faster. So we need to give more superplasticizer dosage to produce a given slump initially. Moving on to the next question. So, what are deformers? So, the question is, what are deformers? Options are as follows. They are forming agents in air entrained concrete. Option B, they are admixtures to prevent air entrainment. Option C, they are chemicals that prevent the bacterial growth in organic polymers. Are they chemicals which facilitates effective dispersion of superplasticizers? So, what are deformers? So here the question is, what are deformers? Are they forming agents in air entrained concrete, or are they admixtures to prevent air entrainment? Are they chemicals that prevent the bacterial growth in organic polymers, or are they chemicals which facilitate effective dispersion of superplasticizers? Okay, so I've received the answer as forming agents in they are forming agents and they prevent bacterial growth. Okay, so I'm waiting for more answers. So I have received A, and C. Okay. A, C. Okay. I'll wait for a few more seconds. Okay. Moving on to the answer. The correct answer is B. They are admixtures to prevent air entrainment. See, formers and deformers. Okay. So the name shouldn't confuse you. They are deformers, which means that they are against the formation of foam. Okay. So it is deforming. Okay, so that means that it doesn't allow the formation of foams. So it is something which does not allow the formation of foam. So they are admixtures to prevent air entrainment. So the correct answer is B. Okay, so keep that in mind. So the name shouldn't confuse you. In fact, the name should lead you to the answer. Formers, I agree. It can, they are forming agents which increases they are forming agents in air and train concrete, but deforming means removing something, or it is against something, so against forming, so admixtures to prevent air entrainment. So they are deformers. So deformers are the admixtures to prevent air entrainment. So the correct answer is B. Okay, moving on to the next question. Accelerators increase the dissolution of dash. Calcium ions, aluminates, silicates, both calcium ions and silicates, or both calcium ions and aluminates. Accelerators. So you all know what accelerators are. They're majorly used in the case of cold weather concreting, when we need to speed up the process of hydration, or when you need to remove the foam work very fast. In those cases, we use the accelerators. So there are different types of accelerators. Generally, the principle is that they increase the dissolution of certain ions. So the question is whether they increase the dissolution of calcium ions, or aluminates or silicates, or both calcium ions and silicates, or both calcium ions and aluminates. Okay. Okay, I can see that I have received so much responses. Thank you. Harsha, Bharat, Nikhilesh, Sharanya, Riya, Anantraj, Balu, Sharat, Shrish. I have got wide variety of responses, I guess. I have A. Okay, VS Reddy. Yeah. A, C, A, C, B, C, D. Good. Okay. I'll give 2, 3 more seconds. I mean, some a little bit more seconds, so that others who wants to answer, please do answer. At least there are 17 people who can answer to this question in this meeting. So please feel free to express your opinion. No one is judging you. So whichever you feel right, please feel free to express it in the chat box. Okay. So we move to the answer now. The correct answer is D. So I have included the screenshot of the PDF and PPT also here. So here, an accelerated should promote the dissolution of both cations and anions. Okay, so cation meaning so since several anions are present, the accelerated should promote the dissolution of that of least dissolving rate. So that is silicate. So comparing silicate and aluminate, aluminate dissolves very slowly. So like if you are in a manufacturing process, in order to increase the manufacturing rate, we need to improve the weakest link. So, like that, in the case of silicate and aluminate, aluminate dissociates faster. So, what lags behind is silicate. So, we need to improve the dissolution of silicate for an accelerated performance. So, accelerated definitely will increase the dissolution rate of silicate. And it says that both the cations and anions, it should promote the dissolution. So, for calcium and silicates, it will improve the dissolution. So, the correct answer is D. Okay, you're right if you say A and also C, but here D option says it's both A and C. So you have to go for option D. Moving on to the next question. Organic, okay. Organic axle. No, B is not the answer because B is aluminates, right? Yeah, B is aluminates. Aluminates already has a higher dissolution rate. So the generally the accelerator will focus on to the um, ion which is having a slowest dissolution rate. So that is silicate. Okay. So if you are running a relay, you have to focus on the person who has the least speed, because of him you guys might lose. So because similar to that, there are so many cations and anions in this in the cement mix. So in that, the slowest dissolving is silicate. So you have to focus on to silicate. So the correct answer is D. Moving on to the next question. Organic accelerators are chloride based. True or false? Organic accelerators are chloride based. True or false? Okay. Thank you, Shrish and Balu. Others? Okay. 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 So thank you all for responding. Shrish, Balu, Bharat, Sharanya, Ria, V.C.S. Reddy, Mohit, Nikhilesh, Balu, Harsha, and KP Sirao. Yes. So going on to the correct answer. So the answer is B or false. So here, if you see that screenshot from the presentation, so the organic ones are TEADA, triethanolamine or diethanolamine, basically the amines, and the carboxylic acids and formaldehyde. So the whatever chloride accelerators, they are separate. Non-chloride are organic or inorganic. So chloride ones are calcium chloride and sodium chloride. So they are not organic accelerators. Okay. So moving on, so that the correct answer is false, as you have all of you have rightly told. Moving on to the next question. The air entrainers have a hydrophilic main chain with hydrophobic branches. The air entrainers have a hydrophilic main chain with hydrophobic branches. Whether it is true or false. Uh, okay. Shrish, Harsha, Sharanya, thank you all for responding. Bharat, okay. Balu, Nikhilesh. Okay, let me go with Shrish. Shrish, can you unmute and tell why you think it is false, or is there any justification?
Ma'am, it is saying that it has a hydrophobic main chain, which is wrong because for the air training agent, it is a polar group.
Yeah. So there is a
And
polar group, and towards attached to that is a hydrophobic main chain. Is that right?
Hydrophobic chain. A hydrophobic short chain which is attached with
Mm. A polar
uh,
group.
and with the polar group,
Yes. Okay. Thank you,
which
Srish.
is anionic in nature.
Okay. So here telling that there's a main chain which is hydrophobic and with a polar group attached to it. Yeah. So yeah. So let's move to the answer. So I guess many have responded. Mixed answers are coming. So the correct answer is false. So here, as Srish rightly told, the hydrocarbon chain does not have any polar. It is entirely hydrophobic. So there is a hydrophobic chain. There is no hydrophilic main chain. So there is the entire chain is hydrophobic. So the correct answer is false. Moving on to the next one. It's again related to the air entraining agents. So the question is the air entraining at mixtures stabilize the air bubbles generated by the agitation and mixing of concrete by altering the steric hindrance or by altering the charge on the surface of the cement or altering the cement surface tension or altering the surface tension of water. So how does air entraining agents stabilize the bubbles? So generally, when we mix or agitate the concrete, the air bubbles are formed, but the air bubbles will burst and it will just vanish off within the matter of few seconds. It will not be stable. The air entrainers are added to stabilize the air bubbles. So how do they stabilize? So is it by steric hindrance or by inducing altering the charge on the cement surface or by changing the cement surface tension or by changing the water surface tension? So yeah, thank you, Balu, Shrish, Bharat, Sharanya, Mohit, and Ria. I'm waiting for more answers from your end. Om, thank you. So most of you have comment. Okay, I can see mixed responses. So there is steric hindrance, altering the steric hindrance as one answer, altering the surface charge of cement as one answer, and altering the surface tension of water as another answer. So majority of you have commented surface tension of water. Yeah. So the correct answer is altering the surface tension. So air entrainers they uh, change the surface tension of the water and it stabilizes the air bubbles within the cement. Yes. So those who all commented anything other than D, please stay corrected. It is air entrainers work by altering the surface tension of water and stabilizing the air bubbles within the mix. Moving on to the next one. So reducing the surface tension dash the capillary pressure. Reducing the surface tension increases the capillary pressure or decreases the capillary pressure or does not change the capillary pressure. So what might be the correct option? Reducing the surface tension increases the capillary pressure, decreases the capillary pressure, or does not change the capillary pressure. Balu sir, there is no option D. There's only till C. Why everyone is commenting D? Om, there is no option D. Kaushik, there is no option D. I mean, I'm wondering why everyone are commenting D. Okay, decreases. Fine. Let me wait for some more time. C, B. No one wants to go with A. Okay. Moving on to the answer, let me move, or should I give you a few more seconds? Okay, moving on to the answer. The correct answer is decreases. So reduces surface tension, capillary pressure reduces. So they are directly related, not indirectly related. They are directly related. If you reduce the surface tension, the capillary pressure also decreases. So that is why the air entrainers are acting by reducing the surface tension of the water. Now the next question is, what is latex? So this was explained in his lecture, Professor Manu's lecture. So what is latex? Is it the suspension of styrene in water? Option A. Or option B. Is it a suspension of butadiene in water? Option B. Option C. Is it a solid solution of styrene and butadiene? Then option D. Is it a suspension of styrene and butadiene in water? So what is latex? Latex is you might have heard this word quite a number of times. So what is latex? Thank you, Bharat, for the quick reply. Shrish, Anand, thanks for consistently replying in the chat box. Okay. Oh, I am getting so many C's. Solid solution of styrene and butadiene. Okay. Then Rao sir commented it is D. Okay. Shrish also goes with D. Anyone else? What about I think Sharanya? I just remember it as Sharanya. Ria also goes with C. Okay, Sharanya also goes with C. Who else was there? Preeti. I have not heard Preeti yet. So, Preeti, are you there? Why are you not replying in the chat box? You need not even unmute. You can just answer in the chat box. Dharmesh, I have not heard from you either, I guess. That's it, Ria. That's it with Ria. With Ria, it's ending. Okay. Moving to the answer. Unlike the popular opinion, the answer is D. It is a suspension of styrene and butadiene in water. So it is like a solution. It's not a solid solution, it is a liquid solution. So styrene and butadiene are suspended in water that makes latex. Okay, it's not a solid solution. It is a solution in water which is a mix of styrene and butadiene. So stay corrected, please. The correct answer is D. Latex is a suspension of styrene and butadiene in water. Okay, moving to the next question. A watertight system is protected from the action of water under pressure. State true or false. The question is, there is a system, it is a watertight system. What does it do? It can protect that system from action of water under pressure. So there is a watertight system. So water is coming from somewhere with pressure. Will that system be able to withstand? The statement says that it can withstand. A watertight system is protected from the action of water under pressure. Whether this is a true statement or a false statement. Yes. Thank you, KPC Rao. Then, who else? There's just. Okay, Nikhilesh, Balu, Ria. Thank you all for responding. Sharanya, VCS ready. Then, who else? What about. Yeah, Ria also commented. Nikhilesh also commented. Who else was there? Shrish. What happened to Shrish? He was my fast responding person. Yes. Shrish says false. Okay. Read that question again. A watertight system protected from the action of water under pressure. True or false? What about Anantraj? I'm just recollecting the names which I have seen a lot of times in the chat box. Preeti, again, not there. Okay. Who else is there? So the chat ends with Shrish. Okay. Let's move to the answer. Okay. So even though Shrish was a bit behind in the timing, he was right. The correct answer is false. There are two types of systems, watertight or waterproof. So waterproof systems, they are protected from the action of water under pressure, not watertight system. Watertight system, they can protect if the water falls on it, or if it is exposed to water, but not under pressure. So this water under pressure, that is a catchy phrase here. So watertight system cannot protect that system from the action of water under pressure. Okay. So the correct answer is false. Okay, moving on to the next question. Dash based compounds are used in alkali silica reaction mitigating admixtures. So, in the due course of this course, we will learn more about the durability issues, more about the concrete properties, fresh properties, hard properties, etc. So, in the durability part, we will come across different issues faced by concrete systems, one such as the alkali silica reaction. So, it is basically because of the alkalis in the system with the silica from the aggregates, siliceous aggregates and all. So, alkali silica reaction happens. So, that is very problematic to the concrete system. So, there are alkali silica reaction or ASR mitigating admixtures are there. So, in that, the compounds are either magnesium based or sodium based or silica based, silicon based or lithium based. These are the four options for you: magnesium, sodium, silicon, or lithium. Okay, I got responses from Shrish, Riya, Balu, Maleshwari, uh, Charanya, VCS Reddy, and Nikhilesh. What happened to Rao sir? Okay, so yeah, moving on to the answer. The correct answer is lithium, as you all of you have rightly told. So lithium-based compounds, before the alkali could react with the silica, or the silica could react with the alkali, the lithium-based compounds, it binds the alkalis. So this is silica. So it binds the alkali. Sorry, it binds the silica so that the silica is not available for the alkalis. So lithium can bind the silica, so it will not be available. The silica will not be available for any ASR reaction. Since it has that ability, lithium-based compounds are used in ASR mitigating admixtures. I hope that is clear for all the others who are attending. Moving on to the next question, which is almost, I think, the second last question for today. Among the following listed mechanisms, which one is not relevant to corrosion inhibitor? So, corrosion is a severely affecting problem regarding reinforced concrete structures. If you see the structural health also, it degrades, corrosion degrades structural health. And if you see the economic impact of corrosion of a nation, it is very huge because maintenance and rehabilitation of structures, especially in India, it is focusing on how to mitigate corrosion or how to repair the corroded structures, including bridges. So it is a very economically impactful issue in construction industry. So there are corrosion inhibitors which can be added during the time of concrete mixing itself. So what are the different mechanisms in which corrosion inhibitors act? The question is which is not the relevant to corrosion inhibitor. So which is the odd one out is the question. Option A, reducing the tensile stress on drying, film forming, oxidizing or non-oxidizing passivators, and oxygen scavengers. Okay. Oh, I have received many responses for this question. Thank you, guys. So, moving on to the correct answer. Correct answer is A, as you all have rightly told. So, it does not act on the drying tensile stress. It can either form a passivating film, or, yeah, the film forming, or it can oxidize the passivators, or it can make the oxygen not available for the corrosion. So, basically, we'll deal in detail about corrosion in the coming lectures when it comes to durability. But as of now, corrosion, uh, without any doubt, needs oxygen, moisture, and some anode and cathode. Electrolyte, all things should be there. Especially oxygen and moisture are mandatory for corrosion to happen. So, if you regarding oxygen scavengers, if you are making the oxygen not available for the reaction, it will not happen at all. So, that is one method in which corrosion inhibitor works. So the correct answer is reducing the tensile stress on drying, because corrosion inhibitor doesn't have any involvement in reducing the tensile stress on drying. Okay. So we move to, I guess, the last question for today. This is very easy question. VMA enhances the stability of mixes prone to segregation. So VMA is viscosity modifying agent. I hope you all know that as you have watched the lectures. They enhances the stability of mixes prone to segregation. So it's a true statement or a false statement. Thank you, KPC Rao and Bharat. Waiting for more answers from your side. Shrish, Balu, Reddy, Sharanya, Ria. Okay. Nikhilesh. Okay. I guess that's all. It was a fairly easy question. So I guess what about Anantraj? He left or what? Because he was a consistently replying person. Okay, leave it. So the correct answer is true. So it modifies the viscosity. It focuses on the flowability of the concrete. It makes the concrete enough viscous so that we can avoid segregation. So the correct answer is true. So thank you. That's all for today. We'll meet in the next class with the sorry. Yeah, we'll meet in the next class with the week 6 sections. Let me stop recording the session.